Hello everyone, welcome to another video on my channel. This will be the third episode of Next Trillion Dollar Ideas. So with no further ado, let's begin. The first segment is about autonomous ride-hail. Autonomous ride-hail refers to transportation service that uses self-driving vehicles to provide on-demand rides to passengers. The service typically operates through a mobile app that allows customers to request a ride, and the autonomous vehicle picks them up and takes them to their destination without the need for a human driver. It has the potential to revolutionize the transportation industry by reducing the cost of ride and increasing safety and convenience for passengers. Adjusted for inflation, the cost of owning and operating a personal car has not changed since the Model T rolled off the first assembly line nearly 100 years ago. This research estimates that the autonomous taxis at the scale could cost consumers as little as 25 cents per mile, spurring widespread adoption. It is likely that autonomous ride-hail could create an $11 trillion addressable market. At 25 cents per mile, autonomous ride-hail could serve a wider population than does human-driven ride-hail today. In the meantime, research suggests significant demand generation at higher price points based on the value that consumers place on their time. Autonomous taxis are already a reality today, and the first players to scale should become the market leaders. Based on the shift to autonomous electric vehicles, oil demand could decline 30% by 2030. Based on electric vehicle forecast, oil demand is peaking and could decline by 5% or 5 million barrels per day by 2030 and 10% by 2035. Adding the adoption of autonomous vehicles, the capacity utilization of which could be 10 times higher than that for personally owned cars, oil demand could decline 30 million barrels per day by 2035. Autonomous vehicles should have higher utilization rates than human-driven cars, lowering the number of vehicles on the road despite higher number of passengers and per capita miles. As autonomous taxis begin to dominate urban transit, research expects unit volumes to be 26 million and 29 million units lower than today's consensus expectation for 2025 and 2027 respectively. With prices ranging from 25 cents to $4 per mile, robotaxis could be a more attractive option than 60% of short-haul airline flights, based on the time and cost savings including transport to and from airports. These short-haul flights at risk currently generate $100 billion or 20% of all airline revenues globally. Priced at 50 cents per mile, a robotaxi service would be less expensive than more than half of short-haul airline flights. At 25 cents per mile, robotaxi services would be more cost-effective than 90% of short-haul journeys. The cost and time advantage should be more dramatic for group travel. An autonomous taxi for 2 or 3 people could be a better option than 75 to 84% of short-haul airline flights. And autonomous taxis could generate $4 trillion in revenue in 2027. And autonomous platform providers could dominate the enterprise value generated by autonomous mobility in 2027. The next segment is autonomous logistics, which is the use of autonomous trucks, drones, or robots for logistics, and it should lower delivery costs and increase convenience. Autonomous vehicles that roll and fly could lower costs across the supply chain. According to this research, autonomous vehicles should operate at higher utilization rates than human-in-the-loop systems, creating more cost-effective delivery systems for small volumes in the last mile. And like autonomous ride-hail, robots and drones should have a greater impact in countries with high delivery fees and can help food delivery platforms to lower their costs greatly. Real-time autonomous delivery could generate a $1 to $2 trillion addressable market in 2030, while drone and robot delivery could price profitably at 20 to 40 cents per trip. current fee structure for mail and real-time delivery could support price points as high as $10 per delivery in the short term. Meal and parcel drone delivery could be a larger opportunity than initially estimated. Based on higher initial price points, drone delivery fees could total $500 billion for parcel and $200 billion for restaurant meals, 5 times more than research previously estimated by 2030. Drones could carry more than half the $20 trillion in e-commerce and the $2 trillion in meals in 2030. The acceleration in growth toward the end of this decade is pointing to super exponential growth. Online grocery shopping accounts for only 6% of grocery sales globally. Interestingly, shoppers in the US pick up online grocery orders 30 to 40% of the time, a figure that should shrink with convenient, inexpensive robotic delivery. This delivery system could generate $40 billion in fees by 2030. At that time, e-commerce could capture 35% of the $11 trillion grocery market globally, with robots accounting for more than half of the deliveries. Parcel and food drones are likely to generate more than $700 billion in fees by 2030. Google Wing, Amazon Prime Air, and many more companies are developing drone and robotic delivery solutions either in-house or through partners. In this research view, companies that own and operate the autonomous technology stack will win the lion's share of the economics. Autonomous trucks should become more cost-effective than rail by 2030. Door-to-door trucks should offer significant speed advantages over rail, taking share from intermodal transport. Aurora, Waymo, and Pony AI are examples of companies developing autonomous truck platforms. Global autonomous delivery revenue could total $1 to $2 trillion by 2030. Autonomous logistics should help companies transport goods to consumers and businesses much more quickly and conveniently, likely changing buying patterns and reshaping global supply chain. The next part is robotics and 3D printing. The adoption of automation typically accelerates during recessions and crises. The adoption of industrial robots accelerated after 2002 dot-com burst and again after the 2008-2009 crisis. The responses to the China-US trade conflict in 2019 and supply chain bottlenecks from 2020 through 2022 have been the same. Robot performance has improved 33-fold in the past 7 years. Advances in computer vision and deep learning have increased this performance of robots. And Amazon could be approaching an inflection point in robotics. Amazon is producing 1,000 robots per day. Within the next few years, it could add more robots than employees per year. And the opportunity for robot penetration in manufacturing is immense. Amazon is in the early days of mass robot adoption, pointing the way for the other industries. To reach Amazon's robot density, the US manufacturing industries would have to add 4 million robots, roughly 6 times the unit sales of industrial robots globally today. What is the upper bound for robot density long term? And on the other hand, 3D printing should impact many industries. This research estimates that 3D printing will be $500 billion market opportunity as applied to existing products. 3D printing is likely to enable new products and markets. Boston Dynamics' Atlas humanoid robot, for example, achieved the strength-to-weight ratio that enabled leaps and somersaults thanks to 3D printing. And the barriers to 3D printing adoptions are materials, costs, know-how, and processing. 3D printing costs should be compared to those over the lifetime of a part, from design to retirement, in traditional manufacturing. While upfront costs can be higher, 3D printed parts can be produced much faster with more durability than parts manufactured traditionally. And in healthcare, 3D printing can make a big difference in the operating room and beyond. Doctors use patient-specific 3D printed models to pre-plan surgeries and customize 3D printed tools or surgical guides for procedures, shortening operating room time and improving patient outcomes. Across the range of surgeries, 3D printed tools, guides, and models reduced operating time on average by 30% and increased performance measured by surgical accuracy and result on average by 40 to 50%. According to this research, 3D printing could reduce total time spent in US operation rooms for all surgery types by 5%, saving $12.5 billion. Worldwide cost saving could reach $80 billion based on surgery time alone, before accounting for improved accuracy, reduced complication, and faster patient recovery. This could increase access to surgery around the globe by reducing costs and increasing throughput. Health systems and services fall short of patient surgery demand by roughly 140 million cases per year. And advancements in AI also improved 3D printing accuracy, strength, and repeatability. Using sensors and machine learning algorithms to control the print process, researchers reduced print error by 30%, strengthened products by up to 2 times, and reduced waste in material by 40%. Research expects the enterprise value for robotics and 3D printing to scale 80% at an annual rate during the next 8 years, from $70 billion today to more than $9 trillion in 2030. The final chapter is about Orbital Aerospace. Reusable rockets should lower launch costs by an order of magnitude or 2. SpaceX put an end to soaring launch costs with its Falcon 9 reusable rocket. Falcon 9 has flown the same booster 14 times. Thanks to reusable rockets, SpaceX nearly doubled its launches to 61 rockets in 2022. And SpaceX is refurbishing rockets in record time. Thanks primarily to rapid turnaround time, the first stage of Falcon 9 costs less than $1 million to refurbish, according to this model. In contrast, each space shuttle launch costs $1.5 billion. Lower satellite launch costs should enable continuous global coverage with low latency. While satellites launch into geostationary orbit technically offered global coverage, latency limited compelling broadband internet experience. Today, companies are launching thousands of low-cost satellites into low Earth orbit and enabling continuous global coverage with low latency and direct-to-mobile device connectivity. And on the other hand, antenna costs could drop to a few $100s by 2027. This research suggests that as cumulative production reaches 6 million units, antenna costs could drop from roughly $500 today to $300 by 2027. In fewer than 2 years, SpaceX has produced 1 million Starlink terminals. The number of satellites scheduled for orbit should increase as costs decline. Vertically integrated rockets and satellite launches should sustain the cost decline of rocket launches. And satellite broadband could generate $84 billion in annual revenue over the next 10 years. Thank you for watching my video. Please like and subscribe so you wouldn't miss the next videos.